Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Okay, so we're going to start by writing this out a little bit bigger, give us a bit more space. So it's minus 6x is less than 60. And we're going to do our tram lines down. And we're going to start by dividing both sides by minus 6. Because that's what this is doing. It's timesing the x by minus 6. So I'm going to divide both sides by minus 6. So that gets rid of the minus 6 on the left-hand side. And it's going to be 60 divided by minus 6, which will be minus 10. Now we've got to be really careful here, because whenever you times or divide both sides by a negative, you must switch the inequality. So instead of pointing to the left, it's now going to point to the right. So our answer is x is greater than minus 10. So we're going to first of all work out where 9 is on the y-axis. Well, we've got 8 here and 10 here, so 9 will be halfway in between. And what we're going to do now is just draw a line across at 9, and then wait until it hits the line, and then we're going to draw a line down, and you can see here that x is 1. So our answer is that x equals 1. So this question says that Adrian, Ben and Charlie have some sweets, and the ratio of Adrian to Ben to Charlie is 9 to 6 to 13. But it also says that Charlie got 56 more sweets than Adrian. So there's 56 more sweets. Well, looking at the actual parts of the ratio, there are 4 more parts. So plus 4 parts, which represent plus 56 sweets. So the 4 extra parts are worth 56 sweets. So 4 parts are worth 56 sweets. So 1 part would be 56 divided by 4, which is 14 sweets. So all we need to do now is work out how many parts there are. Well, there are 9 plus 6 plus 13 parts, which is 28. And each part is worth 14 sweets. So the total number of sweets will be 28 times 14. So 28 times 14 is 392. So when you read this question, the question's basically asking you to find the bearing of O from B. So the lifeboat is at B, so I'm going to draw a north line here. And to find a bearing, you start from the north line and you keep going clockwise. So we're going to look for this angle here. Now, this angle, which is given to us in the question, and this angle here, which I'm just going to call x, are going to be equal. So x is going to equal 135 degrees. And the reason for that is we've basically got, and I'm just going to draw or extend the north line down, because we've basically got we have a set of parallel lines here, and we have a set of z angles, which we know is alternate angles. So the reason for that is it's alternate angles. And always show the reasons to the examiner. Okay, and so to find out what the bearing is, so the bearing of O from B, it's just going to be 360 take away 135, and the reason for that is angles on a point. We've run out of space. Okay, so we're going to do 360 take away 135, which is 225, and so our answer is 225. So factorise means to put it into a bracket, and it looks like it's a quadratic here, but it's actually just a linear factorising because we don't have a number term. So we're going to just use one bracket for this. And looking at these terms, I'm going to focus first on the numbers. So 20 and 30, I can divide both of those by 10, and that will leave 2 and 3. So that's the numbers done. Next I'm looking at the t terms. So we've got t squared there and a t there. So we can divide out a t, but that will leave a t on the first term. And finally I'm going to look at the u, and there's just a u on both of them. I can factorise out, and actually that just leaves nothing on the inside of the bracket. Now always when you do this, expand the bracket to check if you've made any mistakes. So I'm going to do smiles and rainbows. There's loads of different methods. So 10 times 2 is 20, t times t is t squared, and then the u, plus 10 times 3 is 30, times t times u. So we know we've got the right answer. So our answer is 10tu brackets 2t plus 3. There are two rules for things to be in direct proportion. The first rule is you must have a straight line, which we do on this question. The second rule is it must go through the origin. So we're looking for a line like this or like that, somewhere in that region there. Now this red line does not go through the origin, so A and B cannot be in direct proportion. To find the exterior angle of any polygon, we do 360 divided by the amount of sides. These are decagons, which means they have 10 sides. So the exterior angles will be 36 degrees. And the exterior angle is just an angle that kind of continues on. You just continue on from the side. So this one here is the exterior angle of the left-hand decagon, and this one here is the exterior angle on the right-hand decagon. So altogether, the angle A will be 36 plus 36, which will be 72. So our answer will be 72 degrees. So we're going to start just by writing this out. So m equals 7 brackets x minus 10. And we're going to put our solving lines in. I'm going to start by expanding the brackets. And we don't need to. We could divide both sides by 7, but I think this is a bit easier. And we're going to subtract, or we're going to add 70 to both sides. So we're trying to get x as the subject. So we're trying to get x on its own. And we're next going to divide both sides by 7. So we have m plus 70, all of that over 7 equals x. So x equals m plus 70 over 7. So we know that the exterior angle is equal to 360 divided by the amount of sides, which we can just call n. And something you can do is actually just swap these two things around. And we can say that the n, the amount of sides, is 360 divided by the exterior angle for a regular polygon. So we just do 360 divided by 5, and that gives us 72. I'm going to write this out just a bit bigger so we can see what's going on. And there are loads of different methods for expanding brackets. I'm going to use smile and rainbows. So smile there, rainbow there, and I always put a little notch here to remind me to times it. So we're going to do 4 times 8, which is 32, and x times x, which is x squared. Then we're going to do 4 times 3, which is 12, and x is just there. So when we expand that, we get 32x squared plus 12x. When something is cubed, you times it by itself 3 times, so we're going to do the same here. So we've got 5x to the power of minus 6 times 5x to the power of minus 6 times 5x to the power of 6. We're going to put the 5's together, so 5 times 5 times 5, and the x to the power of minus 6's together. 5 times 5 times 5 is 125. Now when you times powers with the same base, which we have here because they're all x to the power of minus 6, you add the powers together. So minus 6 plus minus 6 plus minus 6, which is going to be minus 18. Something else we could have done is we could have done 5 to the power of the 3 here, 125, and then done minus 6 times the 3, which would have given us minus 18. So I'm going to write the question out. So y equals x plus 15. And we're told that we want to make x the subject to the formula. Now what that means is we want x on its own. What's stopping x from being on its own? This plus 15. So to get rid of it, we do the inverse, the opposite of plus 15 to both sides. Take away 15. So we end up with having y minus 15 on the left-hand side, and we've got rid of the plus 15, so we've just got x on the right-hand side. So x is equal to y minus 15. So with each of these pools, try and imagine it being filled. So pool A, first of all, we've got water coming into it, and it's actually going to go quite quickly initially, and then it will hit a point at the end where actually it will go really quite slowly because it's a wider pool. So we would imagine that the graph for pool A would actually go quite quickly at the start, and then at the end it would go much slower. And that doesn't really describe, the red graph doesn't really describe that at all. So for pool B, we start off actually quite quickly because it's quite thin, and then we have a wider bit here, so it will go slower here, and then we go quickly again. So we need a graph that starts off quite quickly, then goes slowly, and then goes quickly. And the steeper the graph on our depth time graph, the faster it's filling up. And that red line doesn't really describe that either. Pool C, however, we can see it goes slowly at the start. And then because it's thin, it will go quicker. So nice quickly. And then it will go slowly again. Well, that is a perfect description of the graph that we're given. So the graph we're given is definitely going to be for pool C. When you have a fraction, it's just a fancy way of showing a divide. So this is x to the power of 11 divided by x to the power of 3. And indices rules say that when you divide two powers with the same base, you subtract the powers. So it becomes 11 take away 3. 11 take away 3 is 8. So that's x to the power of 8. To find the gradient, we need to find 2 points we know on this graph. So I'm going to pick that coordinate and this coordinate here, and we know that we need to draw a right angled triangle between them, and we find the gradient by the change in y, which is 3, over the change in x. But notice the change in x is 1, so it's going to end up being 3 divided by 1, which is just 3. So a different definition of the gradient is for every 1 we go to the right, how far up we go, which is 3. So we need to first of all work out what the length of the side of the square is. And to do that, what we do is we get the 44v to the power of 4, w to the power of 5, and we just divide it by 4. And to do that, all we need to do is just divide the coefficient by 4. So it'd be 11v to the power of 4, w to the power of 5. Some people will try and do something with the v to the power of 4, w to the power of 5. But if you think about it, if I just draw out my square, if it's 11v to the power of 4, w to the power of 5 all the way around, when you add, you don't add the v to the power of 4, w to the power of 5. It's just going to be 11 lots, another 11 lot, another lot of 11, and another lot of 11. So it's 44 v to the power of 4, w to the power of 5 in total. And to work out what the area is, we obviously are going to square that. So we're going to do 11v to the power of 4, w to the power of 5, and we're going to just times it by itself, which is what squaring means. Okay, so we're going to times the 11s together, so that's going to be 121. Going to times the v to the power of 4s together, and remember with indices, if you times two powers of the same base, and they're both v, then we just add the powers together, so that'd be 8. And we're going to add the w to the power of 5s together, so that makes 10. So it's 121 v to the power of 8 w to the power of 10. So we can't work out length CE directly, but what I'm going to do is I'm going to start off by finding length BC. And I'm going to do that using trigonometry. So we've got the 90 degrees there. So it will be, well, we'll start by labeling it. So BC is the hypotenuse, the opposite here and adjacent here. We're not using the adjacent. So we're going to just do our SOHCAHTOA, and we've crossed out the A, so we cross out these two. So it's going to be sine. So we know that sine 79 equals the opposite, which is 29 over the BC. So I'm going to put my solving lines in. And we need to times both sides by BC first of all. So we end up with BC sine 79 equals 29. And we're just going to divide both sides by sine 79. Just a bit of rearranging. So BC will be 29 over sine 79. And when you do that on the calculator, you get 29.542, blah, blah, blah. Okay, so next thing we need to figure out is angle BCE. So where are we? This angle here. And to work that out, we're just going to take 79 away from 90. So angle BCE is 90, take away 79. And that's going to be 11. So we know this is 11 degrees here. And we have enough information now to work out CE, because we've got this triangle here, and we've got this length here, the BC, and we've got this angle here. So we've got enough information now. So we're going to look for length CE. We're going to first of all label the sides. So we've got the opposite here, the hypotenuse opposite the right angle here, and the adjacent here. So this hypotenuse is now an adjacent. We're not using the opposite at all, but we are looking for the hypotenuse. So let's do our little triangles now, find out which one we're using. So we're not using O, so we get rid of sine and tan, and it's going to be a cos. So it's going to be cos 11 equals the adjacent, which is the BC value we've just worked out, over the hypotenuse, which is CE. Now hopefully you've realised from when we did it with the sine thing here, that actually we can just swap these two things over. So we can have it as CE equals 29.542 blah 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 over cos 11. Okay, then we put that into our calculator and we get the answer of 30.095 blah blah blah, and it wants it to one decimal place, so that will be 30.1. So this question will probably need a Venn diagram just to make it a bit easier. So I'm going to draw a Venn diagram. You don't need to. If you can work out how to do this question without, you can do, but I think this is a really tricky question to do without a Venn diagram. So it says that they picked two activities. It was either painting, which I'll put as a P, and sport, which I'll put as an S. So let's start filling in the information it gives us. So 11 picked painting and sport, so that will go in the middle, because that is painting and sport, and 11 didn't pick painting or sport, so they can sit on the outside. Now here's the problem. It says twice as many people picked sport than painting as one of their activities. So it's saying that the total number in, and let's just show it, the total number in the sport circle is twice as big as the total number in the painting circle. Now, what we can do is we can say, okay, So if the painting we label as X, then the sport will be 2X. But if you look, we've already got a number already in the sport, that 11 there. So in algebra, this will be 2X, take away the 11 that we already know about. And the painting is the same. We know the whole thing is X. So what we're going to do is we're just going to take away the bit we know there, which is the 11, and it will be X minus 11. Now we know that there are 66 students in total. So what we can do now is add up all of the parts of the Venn diagram and get it equal to 66. So X minus 11 plus 11 plus 2X minus 11 plus 11, and all of that will equal 66. This is going to be some solving, so we're just going to put our lines in. Now here we've got X plus 2X, which is 3X. And if I put my tool right, there we are. And we've got minus 11 plus 11, minus 11 plus 11. Well, those just cancel out. So we're left with just the 3X equals, and then 66. We're going to divide that 3 both sides. So we've got X equals 22. So if we go back to our Venn diagram now, we can fill in the blanks. So instead of X minus 11 there, we've got 22 take away 11, which is just 11. Instead of 2X minus 11 there, we've got 22 times 2, which is 44, take away 11, which will be 33. So it says, find the amount that picked sport and not painting, which is this 33 here. Something we know about rectangles is opposite sides are equal. So these two will be equal. And these two will be equal. And you notice now that we've got simultaneous equations. So what I'm going to do is get the coefficient of the y the same. And I'm going to do that by multiplying everything in the second equation by 3. So we get 6x plus 9y equals 123. And I'm just going to write in the first equation underneath, because with simultaneous equations we work downwards. Now looking at the signs, they are the same, and the s in same is the s in subtract. So we're going to subtract going downwards. We're just going to subtract going downwards. So 6x take away 3x is 3x. 9y take away 9y is nothing, which is good. That's what we need. And then 123 take away 93 is 30. We're going to get our solving lines in, and we're just going to divide by 3 both sides. So we've got x equals 10. So we know what x is, but we need to find out what y is. So what I'm going to do is I'm just going to pick one of the equations. I can pick the 2x plus 3y equals 41, and just substitute the value of x in. So 2 times, instead of x, it's times 10, plus 3y equals 41. So it would be 20 plus 3y equals 41. Get my solving lines in. And we're going to take away 20 both sides. So we've got 3y equals 21. And then we're going to divide by 3 both sides, if I don't run out of room. So y equals 7. So we've got x equals 10, y equals 7. Now I could check that with the first equation as well. So 3 times 10 is 30, 9 times 7 is 63, 30 plus 63 is 93. So we know we've got it right. To add column vectors, all we need to do is add the tops and add the bottoms. So 3 plus 7 is 10, and 4 plus minus, or just 4 minus 5, is minus 1. So our answer is 10 minus 1. So we're going to first of all draw a tree diagram for this information. You don't have to, but it is easier to understand what's going on. And so the first choice will be the first pick. It'll either be male or female. And the second choice will be the same, male and female. And looking at the questions, there are 3 male names in the hat and 5 names in total. So the fractions for the first one will be 3/5. If there's 3 male names, there'll be 2 females. Now, if we've picked a male name already, there'll be 2 left and 4 left in total. If we haven't picked a female, there's still 2 females, but there's 4 left in total. If we picked a female, there'd still be 3 males and only 4 left in total, but there'd only be 1 female left. 1 female name left and 4 left in total. Okay, we're looking for the probability that the genders of the names are different. So looking at the outcome here would be male-male. That's not what we're interested in. Here would be male-female, we are interested in. Female-male, we are interested in. And female-female, we're not interested in. So we're not interested in these ones. And the way that tree diagrams work is as you go along the tree, any fractions you go across, you multiply together to find the outcome. So this will be 3/5 times 2/4. And I realise I could cancel 2/4, but I generally cancel at the end. So 3 times 2 is 6, 5 times 4 is 20. We're going to do the same with the other root. So 2/5 times 3/4. So 2/5 times 3/4, 3/4. That would be 6/20. Now we're looking to see whether it was male and female or female and male. And the word or in probability means add. So it'd be 6/20 plus 6/20. And this is the probability of different. Which will be 12/20. Now 12/20 will cancel to 3/5 or 3/5. So this question is asking us to find the probability of not A and B. So if we look at and I'm just going to quickly draw out a similar Venn diagram. So if this is A and this is B, then not A will be everywhere apart from A. So it will be all of this here. And if we do the same thing again, and this time we're interested in where B is, so we've got A and B, then B is this part here. So if you have a look and see which are shaded in both, you can see that this part here is shaded in both. So this part here is not in A and is in B. So it's this 3 here. So the probability is going to be that 3 over the total amount. So all of these added together, which is 25. First thing we need to do is find out what 10% of the 109 is. So we're just going to multiply by 0.1. And that gives us 10.9. So what we're going to do is we're going to add and subtract this from 109. So we're going to do 109 take away 10.9, which gives us 98.1. And then we're going to do 109 plus 10.9, which will give us 119.9. So our error interval is between 98.1 and it says to use t, and 119.9. This question relies on the fact that you know what the equation of a circle is. And the equation of a circle is x squared plus y squared equals r squared. Now r is the radius of the circle. So when I rewrite this, and I write it with our 16 there, we can actually rewrite 16 as 4 squared. Okay, comparing this equation to this equation, we can see that r is 4. Now this equation, the x squared plus y squared equals r squared, gives a circle with the center at 0, 0, at the origin. So it means that the radius will be 4, so the circle will go all the way up here, all the way across here, all the way down here, and all the way across here. Now, I am really, really bad at drawing circles, and so what I would recommend you do is use a compass and measure out 4 and join these up. I'm going to try my best. I don't have a compass that works with this graphics tablet, but I'm going to try and draw somewhat of a circle. There we are. That's probably the best circle I'm going to draw. So what you do is you just get a compass and put the point at 0, and then you would measure out 4 units. So measure it between the 0 and the 4, and then just draw a perfect circle round. So we've got Billy and James and Sam, and James collects 20% more sand than Billy. So we've got James and he's plus 20%. And Sam collects 60% more sand than James, 60%. And you'd think you just add the two. Obviously, it's not going to be that easy for 3 marks. So the answer is not 80. What we've got to do is find the multipliers for each of these. And so what we're going to do is we're going to start off with 100%, add the 20%, and that would be 120%. Then we're going to get the 120, divide it by 100, and that gives us the multiplier, which would be 1.2. So the multiplier from Billy to James is 1.2. So however much Billy has, if we times it by 1.2, we get James's amount. Do the same for James to Sam. So start off with 100%, add 60, is 160%. Then just make that a decimal, so 160 divided by 100, 1.6. So if we multiply anything by 1.6, it will increase it by 60%. Now it says, by what percentage is the amount of sand collected by Sam greater than the amount of Billy? So what we're going to do is we're going to start off with Billy being 100%, okay? We're going to times it by the 1.2, and then times it by the 1.6, and find out what the final percentage is. So when we do that, we get 192. So we started off with Billy's 100, we just made that up, but it just makes the maths nicer to use. And we ended up with Sam having 192. Well, what is 192 as a percentage increase of 100? Well, the reason we picked 100 is we can clearly see that it's gone up by 92%. So our answer is 92%. It tells us in the question that angle OCA is a right angle. So if that's a right angle, it means that OC and AB are perpendicular. If they're perpendicular, that means that x is 5 centimeters. And the reason for that is that the perpendicular from the center bisects the chord. And what that means is that we've got a perpendicular from the center, which is this line here, and we've got it hitting a chord, and a chord's just a line across a circle. But the key word here is bisects. What bisects mean is that it will hit it halfway at the midpoint. So if it's at the midpoint, that 5 centimeters will equal the x. The parts of a box plot are that the lowest value is on this side here. The lower quartile is this bit here. The median is this bit here. Upper quartile, and then the highest value. So the median is this part here, and we can see that is at 23. So the median is at 23. A box plot starts with the lowest value, then it goes to the lower quartile. So we have the lowest value, then the lower quartile, and then we have the median, then the upper quartile, and then the highest value. So lowest value is at 1 on this one, and normally we just put a little kind of line at the end here. So we're going to put a line at 1, and I'm just going to put that line there. Ooh, a little bit further to the right. There we go. And our lower quartile is 9, which is kind of where the box starts. So we're just going to start a box there. We're just going to connect these up. There we go. And our median is 11, so we're just going to show that. Quite a thin box plot so far. Now it says the interquartile range is 5. Now the interquartile range is the distance here, so that's 5. So it's going to be 5 more than the lower quartile. If the lower quartile is at 9, it would be 9 plus 5, which will be 14. So if we get our line at 14, and then complete our box plot. Here we go. Now the range is the total distance of, or the total width of our box plot. So that's 17. So that's going to be 17 higher than the lowest value. Now the lowest value is 1, so 1 plus 17 is going to be 18. So I'm just going to, there we are. And we're going to have that at 18. And again, I'm just going to put a line there. When we draw vectors, the top component of a vector is how far right, and the bottom is how far up. So we're going 4 right and 2 up. So I'm going to just plot a point on our graph, and I'm going to jump 4 to the right. 1, 2, 3, 4. We're going to go 2 up. 1, 2, and our end coordinate is going to be here. So we're going to just join these up with a straight line. The direction is, well, we start at the bottom left and we end at the top right. So the direction is this way, and it says to label it A. So A. I'm going to start by just drawing the line y equals minus 2. So the line y equals minus 2 will be a horizontal line at minus 2, which will be down here. Next, we're going to do the line x equals minus 1, and that will be a vertical line at minus 1. Now here's a bit of a problem. We've got no equal to underneath it, and whenever we don't have an equal to, we do a dash line. So we're going to do a dash line here. Okay, the last graph is a little bit harder. We've got y is, or I'm going to do y equals x minus 3, and it's going to be a perfectly diagonal line, but down to minus 3. So it's going to be this line here, about there, but it's going to be dashed because we don't have an equal to. So it's going to be a dashed line like that. So if they have an equal to underneath, then it will be a solid line. If they don't have an equal to underneath, it will be a dashed line. Okay, now we've got to work out where the region is. So we've drawn the lines, and the lines are either dashed or solid, and so they're perfect, but we've got to work out where the region is. So we can see on the first one that y is greater than or equal to minus 2. So it's going to be above this line. Okay. You can see on the next one that x is greater than minus 1, so it's going to be this side. So we've already narrowed it down to somewhere in this region here. And here we're given that y is greater than x minus 3. So what we do here is we pick a point. So I'm going to pick a coordinate, and I'm going to pick 0, 0. 0, 0 is always my go-to one. Write out the equation, and I'm just going to put a box here. So x minus 3, and fill in the coordinates for 0, 0. So 0, blank, 0 minus 3, 0, blank, 0 take away 3 is minus 3. So what is 0 compared to minus 3? Well, 0 is greater than minus 3. and therefore this coordinate is on the correct side, because if we look, we've got y is greater than x minus 3 is our region that we're looking for. So we're looking for that, that's good. And so our region will be anywhere in this bit here, anywhere at all. And you're asked normally to mark it with an R. I'm kind of colouring it in just because your R can be anywhere within this region. It can actually be at 0, 0. Anywhere within the yellow region would give you the mark. To find the distance or displacement on a velocity time graph, we're actually going to find the area underneath the graph. And to do that, we're going to split the graph into two. And we've got the trapezium on the left-hand side, and we've got this rectangle on the right-hand side. So to work out the area of the trapezium, we're going to do half A plus B times the height. And the two parallel sides are on the left and the right. So it's going to be half times this part here, which is 40, plus this point here, which is 160. And then the height is actually the width. So the height is this bit here, so that's going to be times 2. Those will cancel out, the half and the times 2, so that would be 200. And similarly, to work out the area of B, it's just length, width times length. So that's going to be 3 wide, and again 160 tall. So 3 times 160, which would be 480. And so we need to work out the total area. And we do that just by adding the two together. So 200 plus 480, which will be 680. An exponential growth would show an increase from left to right. But the graph we've got in front of us, or the sketch, is showing it decreasing. So it's going to be a decay. When we add fractions or integers and fractions, we need the denominators of the fractions to be the same. And when we've got an integer, we just convert it to a fraction. And here we've got 9k, and we need to convert that to a fraction that is over k plus 9. And the way we do that is we get the 9k, and we times it by k plus 9 over k plus 9. And effectively, k plus 9 over k plus 9 is just 1. So we're doing 9k times 1. So we're keeping it the same. We're keeping it as 9k. So what we do when we times a 9k or a term by a fraction is we times the top, the numerator of the fraction. So it's going to be 9k brackets k plus 9. And all of that over k plus 9. Expanding the brackets, we get 9k squared plus 81k over k plus 9. And so what I'm going to do is just feed that back in here. And so we've got 9k squared plus 81k over k plus 9, which is just that 9k bit, plus 11 over k plus 9. And whenever we're in this situation here, we just add the numerators. So it's going to be 9k squared plus 81k plus 11, and all of that over k plus 9. And that will be our answer. So let's put that in our answer field. So we're told in the question that y is inversely proportional to the cube of x. So we can show that by y is proportional, there's proportionality, inversely, which would be 1 over the cube of x. Now to convert that alpha, the proportionality symbol, into an equals, we need to introduce a constant to the right hand side. So we get y equals k over x cubed. And all I've done to the right hand side is multiplied it by k. Okay, now we need an instance where we know what y is when x is something, and here we do have that, or it should be the other way around. What y is, well, yeah, what y is when x is something. So we've got y is 10 and x is 7. So we're going to feed those numbers into this kind of equation that we've made. So it's going to be 10 equals k over 7 cubed, or 10 equals k over 343. Okay. And then we're going to multiply both sides by the 343. So times by 343 both sides to find out what k is. And I'm just going to swap them around just to give myself a bit more space. And we're going to have k on the left hand side here. So that'd be 3,430. So k is 3,430. So what I'm going to do is just rewrite this equation here. But we know what k is now. So it's y equals 3,430 over x cubed. And that actually is our answer. Here we're told that y is inversely proportional to x squared. So we've got y is proportional to 1 over x squared. That's what inversely means. And we want to change that proportionality sign for an equals. And to do that, we need to times the right hand side by k. K represents a constant. Next step, we're going to put in x equals 7 and y equals 137.2 to find out what k is. So 137.2 equals k over 7 squared. Well, we know 7 squared is just 49. I'm going to solve that by timesing both sides by 49. And when we do that, we find that k is equal to 6,722.8. Going to get that equation we wrote earlier, and we're just going to rewrite it, but we know what k is now. We know it's 6722.8. And we're going to rewrite that to find out what x is when y is 34.3. So we're going to substitute the 34.3 in. And there's a little trick here. If you've got the unknown at the bottom, what you can do is actually just swap these two over. And effectively what we're doing there is timesing both sides by x squared and dividing both sides by 34.3. So we've got x squared equals 6722.8 over 34.3. And then we want to solve it. So get our lines in, square root both sides. And when you square root, that fraction equals 196. Square root it, it will equal 14. So our answer is x equals 14. With this question, we're going to first of all have to find a length before we can find the length AF. And it does involve us thinking in 3D. What I find sometimes useful though is to draw kind of a 2D representation of the 3D. So I'm going to look at this triangle here, and I'm going to notice that I need to find length BF. That's going to be my objective at the start of this. So I'm just going to draw out this triangle again, but in 2D just to make it a bit easier. And BF is this length here, this is 6, and then this is 9. So we're going to use Pythagoras, so it will be sort of a squared plus b squared equals c squared, so it would be 6 squared plus 9 squared equals bf squared. 6 squared plus 9 squared is 117. And then we just get our solving bit in, just to square root both sides. And I can leave this as square root 117 for now. Okay, the actual length that we want is AF, which is this one here. And I'm going to create the right angled triangle using this bit here. So let's just draw that out. Now the top bit is AB, which is the same as the bottom. It's going to be 14. It's going to be the same as EF. Then the BF we've just found is root 117, and we're looking for AF. And this is the right angle. I didn't show the right angle on the other one, but it should be there. Okay, so we're going to use our a squared plus b squared equals c squared. And a squared is 14 squared plus square root of 117 squared equals af squared. So 14 squared is going to be 196. Now root 117 squared is just going to get rid of the square root, so it's just going to be 117. And when you add them together you get 313. And again get our solving lines in. Square root both sides. And this time we're actually going to square root 313 because we need a decimal answer. So it would be 17.691 blah blah blah. It's equal to AF. And it says to 2 decimal places, so that's going to be 17.69 centimetres. So we have the original y equals fx shown in the graph, and it says it has a minimum at 1 minus 1, so it's this one is the black line here. And we're looking to see the new function, the red function, but we notice that actually it looks very similar. It's a U shape for what we can see. It might not be a quadratic, but it looks like a quadratic. And we notice that the point at the bottom has shifted left 1, 2, 3 spaces. Now it's tempting to think that the new function will be f brackets x minus 3. That would be what would be tempting to do, but when you're looking at transforming graphs along the x-axis, it's actually the opposite of what you think. So the actual answer is f brackets x plus 3. So this one would be wrong. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.